two, one. Good afternoon. Welcome to another episode for Philippine Edu webinars with QSR and GEG Philippines. I am thankful that you are joining us today. And before I introduce to you our guest speaker for today, uh, we are GEGs and there are GEGs around the world. And for GEG APAC, the Asia Pacific region, we also have a gathering which will happen on April 17 to 19. And for the Filipino teachers who are watching, please join us. The group for GEG Philippines Facebook group. Please look for us. And I hope you learned something new for today. So let me introduce our speaker for today, our guest speaker. Our speaker is a Google for Education certified trainer. He is also a Google certified for Education certified innovator, and he is also a YouTuber. So please welcome Seti. Go ahead,
Hello,
Seti.
thank you for having me.
Okay, so take it away.
Yeah, well, today we're just going to have a quick chat about the importance of introducing computing, coding, computational thinking. We'll talk about all those different terms later, but introducing it to young children very early on so that they can really develop that love for problem solving, really. I think that's key. If we can instill a love for problem solving, well, then we can also have students that are not only motivated to keep going, but also when they do hit a wall and when they start struggling in any other subject, they will persevere and they'll sort of try to break through that. So it does impact every single area of learning. And I'm incredibly passionate about coding and computer science in general, because I think it's just such an important skill to pass on to the next generation. So I'm going to share a couple of my reasons for why I think it's important, and then also how you can get started with very young children and start introducing it. I know James, who's also here, is also very knowledgeable when it comes to computer science in general. So hopefully he'll jump in and share some of his ideas as well.
Yes, I forgot to introduce James. James was our speaker yesterday.
I was like looking over slides, and he's like,
He's
well,
our
We
speaker
wouldn't be live if if things like this weren't happening.
Yes, thank you, James, for joining us. And thank you for our viewers right now. Our viewers, Stephen, Gertrude, Superman, thank you for joining us. Poprin, thank you for joining us now. If you have any question, just type it in the comments area and we'll try to answer them as much as possible. Okay.
Yeah, I'll keep an eye on the chat as well. So if there are any questions about anything I'm saying or anything I'm sharing, please do let us know, and I'll try my best to answer them. If I'm not answering them, I'm sure James or Gary will jump in, and we'll try to do our best. The first thing I would say is often when you talk about computing and coding, teachers tend to panic. And the first thing I want to say to everyone watching is please do not panic. Don't panic. You don't have to be a techie to get into coding. You don't have to be a computer scientist to do this. Anyone can get into coding. All you need to be able to do is just look at a problem and say, I'm going to attempt to solve this problem. And if you don't know how to solve it, well, that's absolutely fine. Not knowing is perfectly fine. That's really the big message I always try to share with people when they ask me, how do I get into coding? Well, just be willing to make mistakes, because even the most experienced, successful coder will make hundreds of mistakes every single day, and they will pull their hair out. Look at James. He has no hair left. He's pulled it all out just because of a semicolon or because of something tiny that is missed. So it's just, if you're willing to make mistakes, and if you're not, if you don't get upset about making mistakes, then you can get into coding. You can get started by just looking at how you accomplish everyday tasks. So let's say that you're an early years teacher and you're working with 3-year-olds. Well, you can start introducing computational thinking and coding, but it's going to be in a very different way. You're not going to have them sit down and type up, their code. No, you're going to start by introducing some of the concepts behind it. So, for example, when they're getting ready for school in the morning, well, what are the different steps that they have to complete in order for them to get ready for school? Well, they have to get up, they have to take off their pajamas, take a shower, brush their teeth, and just putting that into a sequence, that's already the first step. You're already working on computational thinking. You're already looking at sequencing, and you're already looking at how things are built. But then putting that into words, that's really what it's about. So, for example, many of our early years teachers, they're already doing this. They're doing this on a daily basis. They just don't necessarily look at it from the angle of I'm coding right now. So you'll have activities in an early years class where they're sequencing different actions, or they get pictures of cutting an apple, and different pieces of that apple are cut out. But they never add sort of a word of, "Ooh, look at that sequence." And just putting that word there, or "Wow, I wonder if we could build an algorithm out of that." And just using that vocabulary really brings it all together, because then as they progress and then they start using tools and software like I'll show you in a minute, then they already have that foundation there. I'm not sure if you would agree with me on that, James.
I think just getting the idea of kids actually solving problems is just so important. And I've done quite a bit on this in terms of just getting people to start to think about those problem solving and the way it works, because I think that's the real challenge.
Yeah, and I think it's also that willingness to make mistakes, and I think that is so incredibly important, because if we're not willing as educators to make mistakes ourselves and do this in front of our students, then we're not sending the right message. And so
Yeah,
I'll often actually make mistakes and then highlight it to just make sure that, okay, that my students see that, yes, I make mistakes. This is, how I'm going to try and solve it now. Or when you've got a problem up on the board, or you're trying to solve something like hands-on and you don't really know how to do it, well, just admit that and just tell them, I don't know, and I'm going to try and find out.
yeah, it's true.
So I think that's a big part.
So
I mean,
maganda.
I think, in fact, one of the ways I like to look at it, and as I say, I've got a small slide I can show you in a minute if you like, is to think about it as, oh, I've lost it, actually ways of solving problems. Don't
Yeah.
take the computational thinking about it. It is just literally problem solving. And I think that's the key thing.
Okay.
Yeah,
Let
and I
me
think that's also the other thing. Teachers that are looking to get into coding and all these other things, they often get confused by all the terminology being thrown around.
Yeah.
So let's say that you're a year 1 or a year 2 teacher, and you're sort of typing into Google, oh, I want to start, I have to teach computer science and programming to my students. You type it in, you'll see hundreds of different ideas and terminology thrown at you.
Some of it is extremely confusing because it's aimed at university kids, and a lot of the materials produced are aimed at. But there is stuff aimed at all the different ages.
Absolutely. I mean, there's some amazing books you can get. If you look at, for example, there's a book called How to Code a Sandcastle. I don't know if you've seen that. It is just brilliant. It is brilliant just how it's set up. And I mean, I've used it with 5-year-olds, and they loved it. And it looks at those, basic concepts of computational thinking of what is the problem, what are the different elements of that problem, and how do I solve that problem. And it's just, and I like how you said it all comes down to problem solving. That's really what it's all about. Doesn't matter how you approach it or the tool you use.
Yeah.
Yeah, you're problem solving.
Sometimes you mentioned earlier that there are a lot of resources online, but teachers are sometimes overwhelmed with too much resources. So what do you suggest? Which resource can they can focus on as a starting point into coding?
That's a very good question. I mean, as a starting point, I would say start with your everyday lessons. And just if you try to read up a little bit on it, then in your everyday lessons, you can start bringing that problem-solving approach into everyday lessons.
And
That would be the first thing. You don't have to print anything. You don't have to prepare anything, like anything in addition to what you're already doing. Just bring it into your lessons. That's the key thing. You don't have to start, exploring a new tool yet.
Yeah.
As I said,
mean-
for example, with the early years teachers, just start highlighting those different steps. Start having children think about the sequence of events. And then if something goes wrong, say, that didn't quite work. I wonder where it went wrong. Let's just quickly write this down. And then just with images or pictograms or whatever you choose to do, just write down that sequence and then say, okay, so where did it go wrong? Oh, here. I put my brush into my mouth before I put toothpaste on it. That's why it went wrong. And then it's just getting just
Okay.
don't be afraid. I
So-
think that's the big thing.
I am excited to learn and share this with other teachers in the Philippines. So, if when they are done with reading and they know how to the systematic way of doing things every day, so how can they apply this in with the use of different tools on or with the use of computers? How can they practice this together with the technology?
Well, first of all, they'll have to carefully think about what technology is available to them. So that is key, because
What's the easiest one, the simplest one?
the simplest pen and paper, simplest. That's the absolute basic. Pen and paper, and giving instructions to each other, and giving. Just start with. If you look up unplugged coding activities,
Oh yeah,
that
yeah.
would be the absolute basic to get started. If you look at some, I've made heaps of little activities. Actually, I can show one. Let me just pull up my. There we go. Yeah, if you just quickly pull up my screen.
Okay.
So
Yes.
this is an example of something. So if you have access to Google Documents and Google Slides, you can start creating things like this. So this is an example of something made in Google Drawings. And so we were working with very young children, and we did some hands-on activities where they had to give instructions to each other. And then it was a team building style activity, and they really loved it. But they wanted to keep going, and we had to move on to other things. So what we did was we had a station in the classroom with loads of these type of activities where they could still do similar things. Think about where the dinosaur would have to go before it went back to his nest, and we have different levels. We have places where the dinosaur has to go to a tree first to eat and have a meal and then return home, and so there's different levels, and this took me about 5 minutes to make in Google Drawings. And that just shows you that the tools we have available, we can start creating resources. We don't have to spend a fortune buying these resources. We don't have to go and laminate everything. Just print this off, slide it into a little plastic sleeve, and then with a whiteboard marker, you can use it over and over and over and over. I mean, this has been, I think some of our students must have done this 100 times, and they just get really good at it. And then you obviously keep challenging them. And then I ask them, okay, well, what do you want next? Oh, we want the same activity, but we want it to be a space topic. So that's exactly what I did. I jumped back onto Google Drawings, and then we just made some space ones. And you can see I've got loads of different ones here. We've got some. This was one for the May the 4th. So we had a little May the 4th fun in the classroom, and so we just made a little challenge here. We added some additional obstacles to this. Now it is important that we always ask them to write it down. That's something I found. I don't know if you've worked with very young students, James, as well, because I know you work a lot with older students when it comes to.
Yeah, I mean, I have taught from 1 to 6 before now, and I think the difference is that it needs to be really touch practical based for the younger children.
Yeah.
Once they can read and write comfortably, then they can go on to coding languages. But for me, it is a lot of this unwired practical stuff at the younger ages, whether it's touching something on an iPad or it's actual physical playing with things. And a lot of people have forgotten one of the oldest things that's been here forever, but is amazing for developing problem solving, and that's chess.
Yeah.
You know,
Yeah.
and
Okay,
Board
most
games
kids
when
in
in
they
general,
school
are
are all
board
doing
games in
that.
general are amazing. I mean, if anyone has young children and you're watching, play games, play board games with your kids.
Mm,
Introduce them to the game of chess, but introduce them to other board games as well, because all these mechanics in board games help them problem solve. They help
mm,
them strategize. They help them, plan algorithms out,
mm.
because that's what they're doing. They're trying, okay, if I go there and I gather that resource and then I move that way. And I mean, it's one of our favorite activities as well at home,
Yeah.
is just to play board games with the kids. And many board games will say, 8 plus, 10 plus. Start with a 4-year-old and just see what he
Mm,
does, and you'll be surprised at what they're able to do.
it's
okay,
true.
sadly, I think a lot of teachers are excited, but how about for the high school teachers, for example, grade 8, 9, 10? So this will be a bit easy for them. So
Yes.
what do you
So
suggest they should?
again, all these things can work in sequence. So for example, if you are talking about actual tools, Scratch Junior would be one of those tools that you can look at. Now, this is again the same principle of you're building up your algorithm and your sequences, but it's introducing different statements.
Mm,
Now, if anyone has ever used Scratch Junior before, you'll know that it's incredibly easy to pick up. They have an amazing resource database on their website with teacher resources, and you can find a full curriculum on how to use this in a classroom. But again, it all comes from that problem solving. So then
Yeah,
as
that's
you progress through all these tools, you get into high school, what's going to be key is that they have that foundation of wanting to solve a problem and knowing how to approach it. Um, Now, obviously, these tools also progress. So we've got Scratch Junior. Then as they get older, we've got Scratch that we can dive into, and I'll show you that in a minute. But Scratch is one of those that's been around for many years. I don't know if you know, James, how long it's been around, but it's just
it has been around a while, definitely. I'm feeling 20, but I'm thinking not quite that long.
yeah, it's been there for a very long time. And so what it
Yeah.
does is Scratch shows you, um, well, it's a bit more, it's still graphical, but it introduces text. So what I always tend to
Mm,
say to teachers asking about Scratch is, once your students can read, once they can
mm,
confidently read, why not move them onto Scratch and just see what they come up
mm,
with? Because you don't want them to get frustrated or upset with the fact that they can't quite read everything.
mm.
Because it's very visual, but text is an important part of Scratch because you do have to type into it.
Mhm.
I don't know if you want me to, would you like me to just quickly
Yes,
open up a Scratch and just show
I'd
you what
like
it looks like?
please show us how it works.
So first of all, as we have educators watching, James or Gary will share a link in the,
I am sharing it now. Scratch that.
there we go, brilliant.
Mm.
So Scratch for
There you go.
So
educators.
this
If
is a
you go
free.
to scratch.mit.edu/educators, you'll find lots of resources for teachers, and you can create a teacher account. Now, a teacher account is going to be different because a teacher account gives you a lot more options that are very specific to using Scratch in a classroom. Now,
Yeah.
once you get into Scratch, basically what it will look like, I'm just going to quickly click on Start Creating to give you an example. Now, obviously, you can see here at the top, I'm not signed in or anything like that. But this is what your interface or your workspace will look like. So here you can place your code. And now whenever you run your code, this will become your actual, the window of what happens. So we see we have a sprite here. Now at the bottom, I can add as many sprites as I want. I can change the backgrounds, but we're not going to do that now. I'm just going to show you a very basic one. I want to click this green flag, and as soon as I click it, I want this sprite to do something. So it's very basic. Well, what I'm going to do then is first I'm going to look for an event, because I've already thought about, what do I want to see happen? Well, when I click on that green flag, and this is where that foundation that I was talking about earlier comes into play. So if you've introduced this to very young students and very young, they learn to speak in this way, because that's always the biggest struggle I've found, is that the students are not always able to verbalize the steps they want to take. But when they make sure they speak it out loud, it really helps them to grasp what they're trying to do. And this goes all the way up to older students. I'm sure that James will agree with me that sometimes they just have to walk away, or they just have to talk through their problem and just
Yeah,
start
it's
talking.
amazing how I start walking towards a student, and by the time I've got there, they've thought it through, because it's
Yeah.
just the release of the stress. Okay,
Yeah.
teacher's going to come help me. Oh, actually, here's the solution.
Yeah, and just also just saying it out loud, just like, oh, well, this
Yeah.
is not working. Well, I wonder why. But oh, I forgot that. And then it's just speaking it, saying your code out loud. So when I click on this green flag, I want to change the way this sprite looks. And so again, you can see it's all very clear. It's color coded. I mean, as you use this more often, it's going to become easier. So I'm going to change the look, and I'm going to switch my costume. That's just very basic. You can see there's 2 costumes here, and at the top here, there's a tab that says costumes. Now there's already 2 costumes built into this default sprite, so I don't have to add anything. I don't have to do anything special. I mean, obviously you can add your own. I'm just going to use the default ones. This one is titled costume 1. This one is costume 2. So we're going to go to our code. When I click on the green flag, I'm going to switch to costume 2. So now we can test that. Let's go ahead and click on that green flag. And you can see it immediately switches to costume 2. Now, this is very, very basic, what I'm showing you now. But it gives you an idea of just how simple it is to start building things and putting them together. You can create presentations. You can create games. You can create full-on animations with Scratch. Scratch can also utilize your webcam, and you can interact with that webcam. So you could even create your code where you're sort of swatting away flies, and then every time you touch them, they're gone. So those examples, sharing that with your students, it's going to really motivate them, because they love playing games. But now you're giving them the power to build games, to make games, to create games, and it's going from consuming to creation. And I think
I
that's
would
key.
also stress that at the other end of things is a lot of kids think they've outgrown it, but even the likes of CS50, Scratch has a lot of power behind that simplicity, and you can teach a lot of higher level maths with Scratch. And particularly with distance learning, if you look at the maths functions that are available there, it can make something that could be very dull in maths incredibly intuitive, exciting, and interesting, but also it enables you to have really interactive presentations.
Yeah, I agree, because I sometimes feel a bit like when you get let's say a year 9 student saying, oh, Scratch, that's too easy. Well, actually, create me something. And then you see what they actually create, and you're thinking, well, you're only using about 5% of what's actually available in Scratch.
That's right.
You could do so much more. So it looks very simple, but the power behind it is, I mean, I have fun in Scratch. I mean,
Yeah.
I'm sure James does as well.
Yeah, we all do. And the thing is that, you know, you look at something like Angry Birds. Well, actually, the computing behind it's fairly simple, but the mathematical concepts in there are quite sophisticated. So you have to have a good level of maths to do that. And that's something a 14, 15-year-old would find interesting and challenging. And it's a great way to teach those particular concepts. I mean, we've done so many of these silly triangle puzzles over the years. Well, Scratch enables you to make ultimate. The only problem with Scratch is that it draws it far too accurately.
Okay, we have a question here from Teacher Andre. Teacher Andre is asking, is Scratch accessible with smartphone?
It is now.
Yes. So since they made the move to Scratch 3, they are now accessible on any device. The only caveat there is Scratch Junior is not. So Scratch Junior is not available on every device. It's available on iPads, and it works on Chromebooks because it needs that Android engine. It won't work on a laptop. But the regular Scratch works. It works everywhere.
So iOS, Android, smartphones, all
everything.
Everything.
Everything with a modern browser. The only thing is that certain functions work better or worse on things. So, you know, the touch functions, etc., etc.
And also the screen size makes it, I mean, I prefer using Scratch on a larger screen. It works on the phone, but the screen size might be a bit tricky and fiddly to move things around.
Is there an offline version of Scratch?
Pardon?
What was that?
Is there an offline version of Scratch? Can you install Scratch in your computer, in your laptop or desktop?
Yeah,
There
you
is
can download Scratch for your computer. Yes, if internet's an issue.
because
Let
internet
me find a link for that.
is available, or sometimes there's a low signal of the internet.
Yeah, no, absolutely.
Yeah.
So it is
In regards to working with Scratch and having sort of internet drop in and out, we've noticed that it's actually pretty good at sort of keeping you going, and then as soon as the connection returns, it updates everything, similar to working with Google Docs. So it does have that, which has made it very reliable.
That's great. That's great. Okay. So we also have some comment here from Gertrude. A very informative and interesting lesson.
Thank you.
So much for your comments. Please keep on typing your comments and your question if you have one. Okay.
Definitely. Please do ask us your questions. We're here to try and
I
help.
remember we also have Google has also a resource for Scratch.
Yeah, in fact, it's linked straight off the educator page.
Yeah.
Okay, so
It's linked off the educator page. Yeah.
if you would like to know more about Scratch, you may visit this URL splash on the screen right now, so you are guided. Okay.
Yeah, and there's two different. So if you do want to start using it in the classroom, CS First will use Scratch as well as some other resources, and it's really good in terms of getting started in the classroom. But Scratch themselves, they also have a curriculum. It's called the Creative Computing Curriculum, and it is brilliant. It is just amazingly detailed with lots of resources.
Okay. By the way, if you want to download the installer, you may visit the URL. Thank you, James, for giving me the URL. Okay, go ahead, Sadi.
Yeah, I'm just quickly looking at the comments here, and I see that Scratch is great. Some teachers and parents are curious if there are easy to follow curricula. Absolutely. They have many activities on their websites, even on their homepage. And you can, let me just go back to the homepage of Scratch. Even here, when you look at the top, you'll immediately see some ideas there. But then as you scroll down, they have a separate section for parents and for educators. So let's say that you're a parent, you can go to that parent section there. And then there are here, you have the creative learning approach, learning with Scratch. These are chock full of just activity after activity with tutorials and everything you need in order to start using Scratch at home.
Wow.
I
Exciting.
mean, it has become an amazing resource, because I mean, it's been around for more than 10 years now, and yeah, really has. 2007, by the way, was when it first came out.
And the community as well, the community that is online, it's just, you have educators and students, and then you have just everyone coming together and just really helping out. And you can share your games, which makes it, I mean, that's just brilliant. When you've got a student that spends, day after day working on something, they can share that game and others can play it. And that's what makes it so powerful, isn't it? It's that
it is.
You see someone playing your game and give you feedback.
It was blocked on the iPad and iPhone market for a long time because it was too powerful. It would have destroyed all the apps. It's taken a long time for it to appear as anything on an iPad.
Yeah.
Okay, so we have two resources, mainly from Scratch.
Yeah, I mean, we have a number of additional ones. I mean, if you're looking at, for example, what a lot of schools are now sort of starting to use are these little things, Microbits.
Wow.
Now, a lot of people are really into it, and then obviously now with distance learning, people are panicking a little bit. Now, me being in the makerspace, I love using these because they bring together coding with electronics. And so Microbits have been just, I mean, I've fallen in love with them. But what people don't always realize is that you can start coding and programming with Microbits without actually having a Microbit. You don't need a Microbit. On their website, you can use MakeCode, which is Microsoft's sort of Scratch-like graphical.
Can you tell them if teachers might think that it's too technical, it's too complicated? Is it?
Let me show you exactly what that looks like. So here on the website, so you can go to makecode.microbit.org. Now this website basically replaces the electronics needed to start working with microbits. Now, it is also just full of activities. You can see a flashing heart, name tag, and just for the sake of this demonstration, just to show how easy it is to use, I'm going to open up this flashing heart tutorial. And we're going to start the tutorial, and it's just going to show us how to get started with microbits. So this is what a microbit looks like, and this is what we want to create. So we want to have a flashing heart. You can see this as sort of a smart badge or something you're wearing. And what the microbit has is these LEDs that you can control. So we're going to just get started. And you can see those blocks are very similar to what you just saw in Scratch. So forever, on start, you can recognize this. And what I'm going to do is I'm going to show the LEDs, the LEDs, and then you can start drawing. So if I now choose to not follow the instructions and draw something completely different, here on start, that's what's going to happen here on my microbit. So if you look on the left-hand side, I have my microbit. On the right-hand side, I have the code. So it shows you don't need to buy a physical product to get started. If you are into sort of maker space things and you want to combine some, you want to bring some coding into that, well, you can start with microbit. Now, as we progress, you can see it's going to give us a couple of other information here. So place another show LED blocks. You can just leave it blank. And so we can go back and forth, and it shows us exactly how to do everything. This is very, very easy to get started. This is great for educators, parents, and just people interested in coding, but they might not really know what they're doing. Well, everything is explained step by step. And then when you exit this tutorial, you can get started on your own project up here. Now, there's literally, you can see here, there's dozens of different projects, and they give you lots and lots of little ideas for games that you can create. It's just another really useful resource.
This is a good resource for parents and kids at home right now, especially at this time, to
Definitely.
spending time, with a lot of free time, they can do this. So most probably they will be engaged and think more beyond these examples, right? So they can.
Well, yeah, and if they do fall in love with this, well, they then maybe further down the line or next year or then they can buy a physical microbit, but they don't have to. They can just get started on the website.
Yes, yeah. But if you want your kids to be an engineer or a scientist, well, it's better to start early. So
Ask questions. It's all about asking questions and solving problems.
Okay, so
then let me just move on to the next resource I wanted to share, and I think that our friend James is probably going to talk about this as well at some point. But Code Combat. Now we are getting, obviously, we're looking at some older students now. Now Code Combat it's a freemium offering. So what that means is a lot of the levels are available. They're completely free. But there is also an additional side to this website where you can pay to get access to more tools. However, at the moment, they are also offering schools to reach out to them. And I think James said they jump on a call, and then they'll give you access to the full platform. Now, that is not something you have to worry about. You can get started with the free platform. It's amazing. Everything that's available for free is already great. So let me just show you what Code Combat looks like. Now, this is very much like those games that I really enjoyed playing when I was much younger. And so it's very gamified, isn't it, James? It's sort of, you go through your level.
And that's what makes it, they made the steps very simple to go along.
Yeah. I'm not sure, can you hear the audio or not?
No.
Okay, so there's some very sort of medieval music playing. It makes it a lot of fun. So I'm just going to show you what that looks like. I'm going to open up this level here. This is the very first level. And it also shows you what's introduced. So basic syntax. Well, let's go ahead and get in there. And we can choose our hero. And then here we can choose the programming language that we're going to be using. So you see we have Python, JavaScript, CoffeeScript. I'm going to leave it at Python. I'm going to just select a hero here. Let's go with, there we go, Arrowhead. And you can see this requires that subscription. So this is what's now been made available to a lot of people. However, if you're happy using the first couple of heroes, get started. Let's go ahead and do that now. Let's equip some shoes. You can see it's great fun, isn't it? This gives you additional skills. You can see my health goes up 50.
Thank you.
Very gamified. And then we can play. Levels loading. This is starting to feel a bit like a let's play. Give that a minute to load, and there we go. Oh, there we go. So now the main goal is to avoid the spikes, collect the gem, and it shows you an example of where I'll have to go. Now, when I start that level here, you can see I will control my character by typing the code here, the right-hand side. Shows you different methods here. I can either click on these or I can type it. And so it's very, very basic.
Wow, amazing.
But it gets incredibly complex as you move through the different... So let me just move left and see what happens. There you go. And because it's the very first level, it actually tells me type a move down command. If you heard the audio, you would hear that now. So I'm going to move my character down. There we go. And you can see, move down. We're going to run that code. And there we go. Obviously, that's not enough. So I'm going to have to move left now. So we're going to move that hero left. We're going to run the entire command. And there we go. I'm in the spikes. So you can see that it's, even when you fail, it's still fun. There you go. It gives you an explanation what went wrong, and then you can just change that to a different line of code. There we go. We get a gem, and then we can use those gems to purchase additional equipment, get different skills for our character, and it's just great fun.
Okay.
And there we go.
I'm excited that Teacher Andre will try all the resources that we are sharing here.
Yeah, I really do hope that they try it out, because there's some amazing things that have been created. You can see we move through the levels, and then some of these levels are not available to the free version. You can see here these levels here, down here, this one, these are not available to the free version. All the ones that sort of have this smoke coming off of them, they are available for free. So I would highly recommend anyone interested in coding to just jump in and play some games and learn while you're at it.
If you're a little bit older than that, Pact are offering free workshops at the moment, but they're going to be free for a very limited time. So I've put I have put it in the chat, but maybe not very clearly. Gary, I've also put it in our chat too. So I think it's worth highlighting those. These are for the older students. So I would say these are for 15 to 18 range, maybe 14 if you've got a bit of Python. But they're giving them away during this time, and normally they're $50 and they're professional.
So please take note of the URL and the voucher. That's great.
So you put in the free code. You don't even need your Visa card for that. So you can just literally pop it in and grab them. They're free to keep, by the way. But the Python course is excellent for the older kids, and a great follow-on to Code Combat.
Yeah, definitely. Let me just quickly show you an example here. So there we go. So here you can see some of the available courses. We've got Python, Java, C++. But if you, as James mentioned, if you put in that code, then you can get these for free, and you don't even have to put a credit card.
The two I would recommend to begin with, if you're planning to do IG or A-levels, Python is the world's most popular language these days. But then the other one I would look at is JavaScript. JavaScript can be a bit more finicky for beginners, but it's the world's most seen language, I would say, JavaScript, because every time you see a web page, it's in there. But I mean, to give you an idea, that Python is the #1 language in the world these days by coders.
So can they learn Python without knowing C or C++? Because there
Yes,
are
Python
teachers
is a beginner's language. Yes.
who cannot go away with C++ or C.
Yeah, I mean C++ these days is much more a minority language. C Sharp's being used a lot. Swift's
Uh-huh.
being used a lot. Objective C is being used, but I would say for beginners, Python and JavaScript are the two.
Yeah.
Oh,
And also, I
The
mean,
others are a
if
bit more
you are
special.
coming from a platform like Code Combat, that is Python. So
Yes.
you can dive straight into Python, and it will make sense.
Mm.
The other, if you're in a Mac environment, then yes, Swift is definitely a good one.
Mm. And
okay.
if you do have an iPad at home, Swift Playground is fantastic.
We have a question here from Gertrude. He is asking, the game definitely would develop the problem-solving skills of the learners. However, how can we solve game addiction of our kids?
Yes, well, I
Mm.
think what we're doing
That's
with
this strange
a
to do.
platform like Code Combat, what we're doing there is we're actually using that the intrinsic motivation and then that sort of that point system, and we're trying to harness that addiction and use it for learning. So we're
I mean,
trying to sort of
we are using
turn it around.
gamification there, aren't we? Really. But in terms of development, I think I've talked a lot to psychologists about this recently, and what they've said is you have to look at the underlying causes. If the game is providing an escape and that kid needs an escape, you're going to have to start asking some hard questions about why that kid finds that environment so attractive and
Yes.
what you're not providing in real life. Um,
Mm,
it's a messy business once you start unpacking it. And right now,
yeah.
the WHO has said actually probably the best thing we can all do is play video games because it's an escape from the world and it takes our mind off the fact that we're all stuck indoors. So,
Yeah.
yeah, there's some big questions.
Okay,
I mean, it comes back to the whole. I mean, if you look at someone who has a substance abuse problem and you take that addiction away, well, then there's a good chance they'll just replace it with another substance to feed
Yeah,
that addiction.
true.
So there's definitely underlying causes there, and I think that's
Yeah.
what needs to be solved first.
And neither is a professional psychologist, so we're not going to get into that
No,
too far.
no.
we have another
Um,
question here. Can you recommend which programming language kids should start with?
for me, it would be Scratch. As soon as they can read and write, before that they can play computational thinking games, which are not a language, and then after that I would go on to Python. And Python is accessible at well, we can start teaching at 10 or 11.
Hmm.
Okay, that's great. That's great.
And if you're looking on the other end, I mean, Swift is great. I mean, if you have the iPad, if you have Swift is a separate language, but it's very easy to pick up. And
And
Swift
Playground
Playgrounds.
is great, Ross.
Let me just quickly open it up. So here, Swift Playgrounds. Now it's just this great
It
fun
works
as
on
well.
Mac.
It works on Mac. It
It's a
works on
bit.
iPads. It does not
It
work
is
on
Apple.
any other device.
It's Apple.
Yeah,
It's
that's
In
what
Apple.
Apple
it's a
does.
in a web browser.
No.
Does it work in any web browser?
No, not at
It's
all.
just for iOS. Or,
It is a Mac.
iOS and
okay.
Mac.
Yeah, Mac own. But as I say, Scratch is any browser, and Python can literally work on any browser, any platform,
Yeah.
down to the $35 Raspberry Pi. And there is a more
Right.
basic version of Python for the Microbit.
Yeah. And
Okay.
also many, I mean, Microbit and Python, they work together brilliantly.
They do.
You
Yeah.
can when you do start using microbits in, let's say, at home or in a makerspace, or you can use Python to just do basically anything you want. You can drive motors and servos, and you can do anything. Another one that I would say, if you're interested in it, is if you look at the Edison. I don't know if you've heard of Edison's, James.
I have, but we've had a few safety concerns, I'm afraid.
As in with the meat Edison's.
Yeah.
Okay.
So
So yeah, we've used those as well, and they work really well.
Yeah.
What was
they
that?
are good. They are good, but you have to insulate the battery carefully.
Yeah.
So I've stopped recommending them, I'm afraid.
But their platform is
Okay.
very, very easy to use. The AdPy and the way it all ties together.
Okay. According to Ms. Mina, we will have, since this is a Philippine Edu webinar, we will have a Python webinar from the Google Developer Group from
I'm
Alison.
very excited.
Brilliant.
Very
Man,
exciting. When's
that's
that?
great. Not, I'm not, well, within the until the 7th. I'm not very sure of that. So for those who are tuning in, if you want to learn Python, check the schedule. We have provided it. We have posted it in Facebook. Okay, Seti James, we have few minutes left. Now, for those educators who are still hesitant, what words can you tell them? How can you convince them to go on to introduce coding to kids, and why? Basically, can you make some more suggestion or encouraging words,
Mhm.
please?
Don't be afraid. Please don't be afraid. It's the world is changing, but it is not as difficult as many of us would think to get into it. Um, Start small and start now. And I think that would be my advice: is start small, start now, because it is something you can do it, and you don't have to be that stereotype movie character locked in a basement in front of a computer day in day out. That's not what computer science is about. That is not. That is sort of this image that has been around for a long time, and sadly, a lot of people still see it like that. They say, "Oh, those computer nerds," and it's nothing like that.
How
It can
about
be
you,
great
James?
fun.
How can
Um,
you
I, I,
convince?
I I think it is probably the most important skill of the 21st century, and I think you need to do yourself a service and help your kids. If you're a teacher who cares about your students, then computer science and learning how to solve problems are such essential skills that please do make the effort, because any attempt is good, and it's fine to make mistakes. It's fine to fail. We like to call that in computer science first attempt in learning,
Yeah,
and just do it, because if you inspire, if you help, even if you're not an expert yourself, you're at least going to give people the encouragement to try, because that's where the jobs are. That's where everything's coming right now. Right now, it's Bill Gates that's solving this problem. And we
Yeah,
might not think about it, but he's the one who's developing the vaccine. And the bottom
yeah.
line is, in a crisis, who do you turn to? Well, you turn to a computer scientist. There you go.
there you go.
So for parents, because there are parents who are still watching us, and they are
Hmm.
at the same time educators.
Hmm.
If there are some comments that I heard that, oh, my daughter or my son is not going to she will not take or he will not take
Hmm.
engineering. She'll take or he'll take medicine or law. Will
Hmm.
it be helpful to them if they
Yeah, I
do?
mean,
Absolutely.
if you're doing,
Sorry,
oh,
James. Go ahead.
I was just going to say, if you're doing any science in the UK right now, you're expected to have basic coding ability in Python, because that's the language that science is now using to do data research and that kind of thing. But also, you have to understand that a lot of the basics, a lot of the GP stuff is going to be replaced by databases. There's no danger of nurses getting their jobs taken away, but certainly GPs in the next 10 to 20 years, they are likely to be replaced by computerized systems and chats, particularly when we start to get the data together. So, yeah, if you want to learn medicine, you have to understand that you are likely to be working with computers, and you're likely to be getting involved with programming them
That's
at
And
some
even
point in
higher
the
up,
future.
you're going to be asked to develop algorithms that solve certain problems. I mean, when you
Yeah.
look at, for example, the current crisis and what's going on now with educators, and
Mm,
educators are all getting online. For example, Google Meet. People were using Google Meet and they couldn't see all their students. Well, what happened? A single teacher who actually did understand some code, he wrote an extension, and that extension now gets them to see everyone in a grid
mm,
view. That is going to happen more and more often. More and more
mhm,
often, we're going to turn to people within a profession, let's say education, medicine, any profession, within a profession with that additional skill of coding.
mhm,
Because that's going to become the differentiator between, if I have two people in front of me and they are equally qualified, then the one with the coding skills is going to have an edge. And so I think in the world we're living in now is just coding is incredibly important because it's part
I
of everything. And
I'd
it's
also
just going to keep getting more and more ingrained.
I'd like to add that it's part of the 21st century skills, right?
mm,
It's part of the basic knowledge now for students to know coding, to know all these things. Because if not, they will be left behind. And the demand for this is very high wherever they go, to medicine, to law, to any field. They have to know this, and they will have an advantage, right?
Mhm. Yeah, I mean, as I say, right now, undergraduates in all science in most universities now are expected to be able to use Python first year. So, yeah, the expectation is already there in the UK, and I'm sure it will follow in other universities in other countries.
Okay. We're already extended. So can you give some last words, please?
Yeah, just I mean, the fact that you're watching this and that you're interested, because the title did say coding. The fact that you're watching this, that's already the first step. So, I mean, I would say thank you for watching, first of all, and then don't let it stop here. Don't let it stop here. Take one of the resources or one of the things shared today and just play around with it for 5-10 minutes. Don't just turn off the computer and say, okay, that's it, I'm done now for today. Just take something and just try it out. And try it out this week. Don't wait longer than a week. Just try it this week and just see how it goes.
Yeah, I mean, you've got a fantastic opportunity. Yeah, I mean, right now you have a fantastic opportunity to learn to code.
Okay, thank you.
As I say, what better time when you're indoors to learn to code and give it a go? And don't be afraid as a parent or as an adult. I know Scratch looks like a kid's tool, but give that a go. I would say start there, have a play with it, and pretend it's for the kids.
Yeah, absolutely.
Okay, thank you so much, James, for joining us. Thank you so much, Betty, for inspiring our teachers on how can we introduce coding to kids. Thank you so much.
One last thing, quickly. Mina has said that the Python show's at 8 p.m. today.
Oh, yeah. Okay, Miss Maya. Okay, 8 p.m. today. Thank you so much. Anything that you want to say for Seti? You want to plug your YouTube channel?
Well, it's down there, so here you can see it. But yeah, I mean, by all means, come and have a look at the videos. There's a couple of videos. There's not many on coding specifically. There's some old ones, but just in general, educational technology. If you're trying to do something, if you're trying to get something done, have a look. If you're looking for more specific sort of coding and fun videos, have a look at James's channel, and I think James, your son's channel as well. He has some brilliant videos where he uses coding, and it's just fun and engaging. So,
yeah.
Thank you so much, and we'll see you soon. Okay. Join us also in the Thursday, but for now we'll have an Easter break. Okay. Bye bye. Paalam. Mabuhay sa inyong lahat. Bye bye.
Bye bye.